Daniel Ifediba, and I'm a data scientist. Currently, a contract data scientist. I work with on different projects at different times, and I was a full-time data scientist with Explore AI in South Africa. Yeah, so as a data scientist, I also have the skills of a data analyst. So data analysts are like my junior brothers, yeah. And I'm the elder one. Well, so I'm a data scientist. I help companies make sense of their data and also help them forecast what or tell them what they could expect based on the current data they have at hand, right? So also apart from that, I'm a software engineer in the making. I'm a software engineer in the making, which means that in a few months from now, I'll be a professional software engineer, right? So I'm a software engineer in the making, currently cooking that soup. Currently cooking that soup, which will soon get done. Okay, so I'm going to give the room for every one of us to introduce ourselves before we get to what we have for today proper. So, Stephen, I will start with you. Stephen, go ahead.
My name is Obi Machinemere. I'm a businessman.
Nice to meet you, Obioma. Nice to meet you, Obioma. Okay, Benga, go ahead.
Okay, good afternoon, everyone. My name is Benga Defila. Okay, I work in GIGL.
Hi, nice to meet you, Benga. Hi,
Thank
hi,
you.
hi. Joy, you're next. Can we get to know you?
My name is Joy. I work for Remoni.
Hi, Joy. Hi, Joy. Nice to meet you, Joy. Onyinye, go ahead.
Morning, everyone. My name is Oyenye. I work with a manufacturing company under the procurement department.
Hi, Onyinye. Nice to meet you. Ijoma, go ahead. Can you hear me, Ijoma?
Okay, hi all. Ijoma Paul will be a retired banker.
Hi, Ijoma. Nice to meet you. Nice to meet you. Temi Oluwa, go ahead.
Hello.
Yeah, go ahead, Temi Oluwa.
Hello.
Yeah, go ahead.
Yes,
Good
go ahead.
afternoon, everyone. My name is Temiloluwa Omojaro. I'm a student. I'm doing my master's currently.
Oh, Temi Oluwa, nice to meet you. Nice to meet you. So we have I think few other people in here. So basically, dynamic analysis is it's built on three different values, which is family, where we see our community, um, opportunities flying around, informations are not withheld, which means we give you what you need to know, even when you feel you don't need to know it. One day you're going to get to see the need for knowing that. Okay, and we also it's built on commitment. We believe commitment is going to play a very important role in whatever we want to see as individuals. Whereby if you don't commit to something, you are not deserving of that thing, whatever reward that thing is ought to give. And which takes us to the last value which were built upon, it's called results. We believe commitment is equal to results. If you're committing, you're going to see the results. Okay, so these are the three values in which you're built upon. Okay, and this spans across whether you're learning data analysis, whatever it is you're choosing. Okay, be it data analysis, software engineering, data science, design, UI, UX, whatever it is. Okay, so commitment, community, whereby you have to work with people, having to teamwork with people, plays a very, very important role. Okay, so basically, this cohort is designed to last for 3 months, in which every one of us will work with every one of us, whereby we're going to be divided into study groups, whereby we are going to be divided into study groups, which means that everybody will get to work with everybody at one point in time. Okay, everyone will get to work at one time. Study groups are there to, we believe in even if we are together in a session like this and everyone has access to me or whatever it is I have to give, you all should also have access to each one, because study groups helps you in consolidating what you've learned so far. So if you don't have a study group, it's going to be difficult for you to learn as a person, because if Steven, Adefila, and Joy are in one study group, they get to learn from two different perspectives, which means Steven gets to learn from Adefila and Joy's perspective plus his own perspective, and Adefila gets to learn from Steven and Joy. Right? Everybody are looking at one goal, but there are different ways to get to a destination, which means my way of doing things and your way of doing things are basically different, but the aim is to get to the end of that thing we want to do. Okay, so that is why we have study groups. Study groups play a very important role. How these study groups run is up to you guys, which means your structure, your system of operation is up to you. You get to decide what happens there. But once a study group is not working effectively well, I will be um, I will be pushed to make changes. Okay, so I will be dividing everyone into the study groups, and when it's not working, and or whoever is making this study group not to work will be either taken out from that study group or switched. Study group basically be reshuffled, all that. So study groups are one way we use to learn whatever it is we have to learn. And the other way is questions. Always be open to ask your questions. Confusion is inevitable. You cannot avoid it if you're going into something new, right? Confusion is inevitable. You will get confused at one point or the other. But like I was telling someone last week, we want to get you confused at the start. We are hoping to get you confused at the start, but at the end of it all, we seek to give you clarity. So being confused at the start of anything is normal, very, very normal. But at the end of it all, you should get clarity. That is why we have that is why we have capstone projects. That is why we have videos, walkthrough, like videos that shows you how to do something. And we also have videos that explain things for you to the barest minimum. So you have images explaining everything you need to know and walkthrough videos telling you how to do everything that has been explained for you so far. Okay. And also what we believe in is practice. You have to practice. If you don't practice, no matter what you're hearing, no matter what you're learning, it doesn't stick. So you have to keep practicing, because I myself, being a data scientist, I keep practicing every day. I'm not an expert, but because I've been able to practice, I am no more a beginner. So you have to keep practicing what you've learned. Always keep practicing, even if you don't know what you're doing. Keep practicing. Ask your questions. Ask your peers. Ask me questions. You have access to the group chat. You have access to me personally, which is like 24 hours and 5 days. Okay, not 24 hours basically, but you get what I mean, right? In 5 days, you have access to me. My Saturdays and my Sundays are for resting because I believe you guys always love resting too. So Saturdays and Sundays, you might not really get a response from me, but Monday to Friday, you will definitely get a response from me because my phone is always in front of my face, working. So and also one other thing there is you have to believe that you know nothing. So what I say is you feel you know, hold it on your left hand, okay, because it's going to help you along the way. But whatever we're going to teach you, please hold it on your right hand because it's a new information at some point or whatever point it is. And definitely it's going to help you along your journey. So the course of this entire sprint, so we have some people learning data science, we have some people learning data analysis. Okay, these two things are the same but different because data science has to do with machine learning, data analysis has to do with uncovering trends. Okay, so for the data scientists, you are when it gets to machine learning, you will be separated from the rest. Okay, then for the data analyst, before we get to machine learning, you should be done with whatever it is we're doing. So data analysis lasts from 3 to 4 months, which is not more than 4 months because you'll be doing projects, right? You will be doing projects, but you'll be working with the data scientists. Now we for data analysis we use SQL, Power BI, and Python. SQL is used to write your queries, Power BI to visualize, and Python to do in-depth data cleaning or analysis, right? Then for data science, once we get to Python, it becomes um, like the pressure gets worse. The pressure gets worse because you move into machine learning. It's not difficult, but it requires more focus. Okay, so if you're here and you're doing data analysis, you feel like data science would like to get your hands into, please text me. Okay, since we are just starting. But you should be aware that data science is more like the elder of data analysis, but they both work hand in hand. So in a data team, you should have a data analyst and a data scientist. So I'm going to be explaining what the difference between a data analyst and a data scientist. A data analyst is someone that uses past and current data to uncover trends. Basically, analyze a data. By analyzing the data, I mean looking. Maybe you are going to you're going sightseeing as a tourist, and you find yourself on top Kilimanjaro, or let's just say Mount Everest, and you have this telescope where you are seeing little things on the floor, but you can't really tell what they are. Let's assume those little things are called the data. Okay, then using your telescope or microscope or whatever it's called, you're then using it to view or trying to see, get a very clear view on what these little things are. And that stuff you're using expands or make those things bigger. So they are not little to you, they are now bigger. You can see them clearly for what they are. That is what we call analysis. Okay, so analysis helps you. Data analysis, the tools you use for data analysis, helps you get a clearer view of what the data is telling you. So that's what we call data analysis. And the data analyst and the data scientist work hand in hand because the data scientist sometimes does work of data if there is no data analyst in the company, in the organization. But if there's a data analyst present in the organization, the data scientist sticks to the core duties of data scientists. Now, who is a data scientist? A data scientist basically is someone who uses information or past and current data to make predictions for the future. Okay, so I can say I have the past price of Bitcoin. I have the current price of Bitcoin. As at last year, Bitcoin was like $16,000. This month, Bitcoin is at I think 24, $25,000. I can use this data, look at trends, use the data and predict what Bitcoin will be like from now. Okay, and what I use in making those predictions is called machine learning algorithms. Okay, I use machine learning algorithms to make um, these predictions. So machine learning algorithms are based on mathematics. It could be calculus. Okay, basically calculus. Yeah. So use this calculus, this mathematics to make predictions. But luckily for us, these mathematics are being turned into codes. They're being turned into machine learning models. Okay, so for machine learning models, we have decision trees, random forest, and so on and so forth. I don't want to get the data analysts confused or the people that are just starting data science. So we use this stuff to make predictions. So when I use these algorithms, I can say, okay, 6 months from now, Bitcoin should be 6 months from now, Bitcoin should be at $34,000. Okay, 6 months from now, Bitcoin should be at $34,000. That's what data science does. Okay, that's what the data scientist practically does. Make predictions. Currently, for example, I'm working on a project that I'm able to predict the price of Bitcoin. I'm using Bitcoin as an example. I'm able to predict the price of Bitcoin against the US dollar. Okay, so I've been able to look at use my analysis, my skills as a data analyst to look at the price from last year, the price from January, and the current price in February. Okay, and using that, I've been able to see, okay, there is an uptrend. There was a downtrend from beginning of last year. Now there's an uptrend. It's going up little by little. And from my knowledge of cryptocurrency, it's these things are being used by energy producing companies, something like Tesla or whatever thing it is, maybe Meta, Facebook. And we know that these things, the world is going into a digital age whereby um, organizations will seek to drop the use of currency, there's normal pound, US dollar, and all those stuff. And they will want to go into digital currencies, which Bitcoin is like a leading one. So I can basically say if there's an uptrend at this time and we are slowly moving into the digital age, basically I'm expecting my machine learning model to predict the price towards the upside, which means price should basically be moving towards maybe 40K, 50K. Okay, so I do my data and my analytical side, looking trends and all that. Then I switch into data science part where I then do algorithms and all. Okay, so I'm going to stop here for now and just take questions. So based on everything I've said so far, if we have questions, anybody having a question, please, you can raise up your hand. I'll just click on the raise hand button. That's 5 fingers there, and I'll call you up to ask your questions. Do we have anyone with a question or shoot on? Okay, Joy, I think Joy was the first. Okay, Joy, go ahead.
Okay, question is based on the difference between data science and data analysis. That's just it. I'm a bit confused about it.
Okay, all right, so let's say we have a scale of 1 to 10. The data analyst stops at 6, 1 to 6. Okay, the data analyst measurement stops at 1 to 6, while the data scientist starts at 1 to 10, which means the data analyst can perform fully the duty of a data scientist, right? Because the data scientist duty is both being a data analyst and a data scientist. Now, being a data analyst means you have little or no knowledge about machine learning. Machine learning is used to make predictions on the data. Okay, so maybe I want to look at how much will um, Rolls Royce cost in 10 years time. I use my analytical skills to look at the trends, the price trend from 1990 to date, then to look at how much. So I use my analytical skills to look at the price trend. That's what they call data, the role of a data analyst. I'm just looking at the trends from the data I already have on hand. Okay, so that's past and current data. Why, as a data science, since I've used my analytical skills, the skills of a data analyst or the role of a data analyst to look at trends on past and current data, I can now take that past and current data to make predictions on what the price of Rolls Royce will be 10 years from now. That's the action of making that prediction is now the role of a data scientist. Okay, so what basically differentiates a data scientist and a data analyst is machine learning. Okay, that's the main thing that differentiates a data scientist from a data analyst, machine learning. Okay, they both follow the same process, right? They both follow the same process, but the skills needed are different. So for a data analyst, the skills you might need is SQL, Power BI, Python. You might also need Excel. Yeah, definitely Excel, but Excel is something that's common, right? Then you also need some tools like storytelling. That's soft skills, storytelling. You have something like if you can get AWS, which is the cloud computing works fine. Okay, but for a data scientist, you definitely need Python, right? You need Python because for you to make predictions, you need to write those codes in Python or Java, depends. But Python is the one that's preferable. Python, you need to have your skills as an you need to have SEO, you need to have Power BI, you need to also have Excel, right? You need to have machine learning skills, you need to have cloud computing skills, which is not all really important because that goes to data engineers. Data engineers are the ones with cloud computing skills. I know I've not talked about data engineers because you don't need to bother yourself with that. Okay, so data engineers are the ones with cloud computing skills. Then you need to also have stuffs like model deployment. You need to know how to deploy a model as a data scientist, not just building models. You need to know how to deploy them. You need to also know how to build deployment websites using stuffs like Streamlit. So this is what we use to deploy. Okay. So the major difference between a data analyst and a data scientist is basically machine learning, making predictions. Sometimes data analysts make predictions, but when we're talking about making predictions, they can just do something like predictive analysis or time series forecasting. Okay, but when we're talking about building machine learning, like maybe you want to look at the customers are likely to book a flight, okay, for on British Airways based on the current data you have, and they're just giving you reviews. Definitely, you can't use just basic data analysis to do that. You need to use what we call natural language processing in machine learning to do that. Okay, so it's another field entirely. So if you're doing data analysis, you don't need to know machine learning. You just need to stick with SQL, Power BI, and Python, and also understanding the problem that business needs to tackle. I hope that answers your question, Joy.
Yes, thank you very much.
Right. So, Steven, go ahead with your question.
I was about to ask the same thing just a second. That was what I wanted to ask before, but she said it.
Okay, was my definition good enough for you?
Yeah, it's fine, very clear.
Okay. Okay. Blessing, your hands was okay. Now we've not heard from Bless, right? She has not introduced herself. So Blessing, before you ask your question, please introduce yourself so we can get to know you.
Hi, good afternoon. My name is Blessing Igwe. What should I say?
Okay, so go ahead with the question, Blessing.
And I wanted to also know if it's a prerequisite that you know data analysis real well before you jump into data science. So is it necessary for me to like be very advanced in data analysis to be very good in data science? Thank you. I think that's what I want to ask.
Okay, basically, I would say no. You don't need to be very advanced in data analysis before you become a data scientist. Okay, why I would say that is because,
All right, thank you.
okay, yeah. So why I would say that is because you just need to know what you need to know. Okay, you need to know how to make basic analysis, right? We call this the exploratory data analysis. You need to know the basic analysis on the data you're working on. You need to be able to get basic findings, no, because you can never know everything about a particular data, but you can know some things about a particular data. As a data analyst, you'll be working in a team. That's why I advise you study group. You'll be working as a team because what you're not able to know, someone else might be seeing it. What the person is not able to see, you are seeing it. So when you guys join your views together, it begins to make a whole lot of sense. Okay, so yeah, you might not know everything, but you should know something. Then as you practice and practice and practice, you become good and better at whatever it is you're doing. Okay, so for the data analysis and data science, they follow a life cycle. Okay, this life cycle of data life cycle. You can call it data analysis life cycle or data science life cycle. The first one is you need to gather information, right? Or I can say you need to understand business problem statement. What problem is the business currently facing? You are going to be getting slides and videos explaining these stuff to you guys. Okay, so I will just touch the little since we're just doing touch and follow for everything, right? So uh, the first one is understanding the problem of business. You need to understand what problem is business looking to solve. Okay, what problem? So every business has a problem. So what problem is that business you're working on the data? What are they looking to solve? Then the second thing you might want to work on is okay, you might want to follow after understanding that you'll not be like, okay, where can I get data for this problem to solve this problem? Now there are two ways to get data. It's either internal or external. There are two ways to get data, either internal or external. Internal means the business is going to give you their past and their current data, asking you to work with it. Then external means you have to go and do surveys. So you have to do surveys, get information from other sources as long as they are not within the company. Okay. Then after you've gathered your information or gathered enough data, the next thing you would want to do is analyze, right? You need to analyze this data that you've collected, right? So inside analyzing, I always like to put data cleaning. Data cleaning is simply reducing noise in your data set. So every data is all, in fact, the raw data is dirty and data never makes sense unless it's been cleaned. So if you're collecting data from anywhere, most times it don't make sense unless it's cleaned, unless the data has been cleaned. So you need to clean your data sets by removing noise. Noise, I mean removing blanks, because there are some places in your data that won't contain information. You need to treat those. Okay, and after you've done that, you need to analyze your data. So it needs to go through what we call the exploratory data analysis, which means you need to explore data, find out what your data is telling you. There are different types of exploratory data analysis. we have the graphical and non-graphical. Don't worry, I'm going to be giving you slides containing this so you can read and watch videos explaining them while I break it down for you. Okay, we have graphical and non-graphical. Graphical means you're using charts and plots to do everything. So for those charts and plots, we have histogram. I'm sure we all know what an histogram is. Even if you don't know, this is going to break it down for you. We all know what histogram is. We know what bar chart is. We know what pie chart is, right? Then you might not know what a box plot, scatter plot is, but you're going to be learning about it, right? This stops at the graphical side of exploratory data analysis, simply mean with graphs to do our analysis, right? Then the next side is a non-graphical analysis. This simply means you're looking at descriptive statistics. Descriptive statistics basically mean is a type of non-graphical analysis telling us the summary of our data set, which is the mean, median, mode, standard deviation, the maximum value, and the minimum value. Okay, we'll be explaining everything later on when we go fully into our lectures, right? So another part of the non-graphical analysis is also you want to look at the information your data is telling you. Are there empty values in your data sets? Okay, how many rows and how many columns you have? What is the shape of your data set? So the shape of a data set tells you the amount of rows and the amount of columns you have in your data set. So data set simply means the data you're working on, right? So I'm breaking down these terms. Any term that looks ambiguous, I'll break down. So data set simply means the data you're working on. So you have rows and columns, right? So looking at the shape of that data tells you the amount of rows and the amount of columns you have. Then okay, so the next thing you might want to look at is, are there null values in your data set? There are null values. How many null values do you have? By null values, I mean missing values. We call them null values in data analysis or data science. Okay, how many of these null values or missing values do we have? Okay, so descriptive statistics or non-graphical analysis helps you find that out. Then we also have skew analysis. Is a type of non-graphical analysis that tells you how distributed your data is. Is it a normal distribution or an abnormal distribution? Okay, when we're talking about a normal distribution, it can be seen using an histogram. So skew analysis shows us numbers, so which are going to be explaining later on. But all you should know is that skew analysis is a type of non-graphical analysis that tells us how distributed our data is. Then we also have kurtosis analysis. Kurtosis analysis tells us do we have outliers in our data? Okay, so outliers simply means, let me give you an example of what an outlier is. A very basic example. Let's say in this class, we are all between the ages of 15 to, let's say 15 to 70 years, right? Let's assume 15 to 70 years. Then imagine if we're saying someone that is 299 years old. That's odd, right? So that's an outlier. That age is an outlier, which means it's totally different from everything, or it's totally different from the information we have on our data set, right? So that's an outlier. So kurtosis analysis tells us the extremity. That means how extreme are these outliers in our data sets? So when we're looking at kurtosis analysis and the numbers, we actually get to know if we have outliers or not in our data sets, right? Um, so after that, we are then able to, after looking at this analysis and everything, we are then able to make informed decisions, telling the business what they can do. So after the EDA, we then move to communication of findings. Okay, getting insights and communication of findings to stakeholders. Now that's for data analysis. But for data science, after the EDA, we move to model building. And then after model building, we just build models using machine learning algorithms. adjusting one or two features to um, uh, get our data in check. Then after model building, we'll move to model deployment, which means that we need to actually deploy our models for the outside world to use. Because these guys won't understand machine learning or algorithms, but they will understand how to use a website. Right. So model deployments. And also in data analysis, we do model deployments, whereby we deploy our dashboards to the outside world for them to be able to play with them. Just make changes themselves and do everything they need to do. Right. So that's the life cycle of both a data analyst project and a data scientist project. Okay. So based on what I've just discussed, do we have any question at all? I'm open to take any questions from anybody. Okay. So if we don't have any questions, I will move on. Okay. So the idea of doing this, so at the end of each sprint, we call them sprints. So SQL is a sprint, Power BI is a sprint, Python is a sprint, supervised learning is a sprint, unsupervised learning. Now I'm talking about data science, right? Unsupervised learning is also a sprint. So after a sprint, you will be doing a project, right? And we'll be showing you how to um, get this project ready for the outside world to see them. So you don't just do a project and keep them in your laptop. We're going to show you how to do this project and show them to the outside world, telling them that you know what you're doing and you're coming after them, which means those employers there, you're coming to choke them with your projects. Then after that, after you're done with the entire program, you'll be doing projects with some other international firms working on their data sets. Okay, which means you'll be in communication directly with them. All right. And for now, we are in partnership with just two companies, which means the data you'll be working on will fall under these companies. So why we're in partnership with them? Because they are the ones that have given us go ahead to do what we need to. All right. So working with them, we are discussing with them behind your back. We are not gossiping, but we are discussing with them behind back. Okay. Telling them that there's someone working on their data. That when the person is puts their data on LinkedIn or deploys it on whatever, they're going to be letting the company know so the company can actually take a look at it. So which means that we are going to be vetting your project, like scrutinizing it very well until we feel it's good enough for you to show it to this company. So if we feel it's not enough, you won't be showing it to the company until we feel it's good enough, right? We don't want you to give them on uncooked rice. Just carry raw rice and put it on top with chicken. So we want the rice to be properly cooked, nice stew. If it's Yoruba stew, very making sense. Love that one. It's pepperish, but not pepperish. Then let the turkey be fat. So it's properly cooked for the company to be like, this is making sense. Let's take a look at it. So most likely you'll be called to make a presentation for them and tell them what you've been able to find out, limitations and everything. So even learning all the skills, SQL, Power BI, Python, machine learning, everything. The most important thing I always tell people is communicating your data. If you are not able to communicate your data, it makes no sense. So we are teaching you hard skills and soft skills. Soft skills is communication and storytelling. All right. So we're going to show you how to make stories. We are going to tell you how to say stories. Okay. So you'll be doing presentations every now and then to teach you how to actually um, be good at storytelling. Okay, so you don't have to worry about that. That's why you're working with team on a team and you're working with us. So apart from the study groups, you'll be shared into teams. You're going to come say a story, you're going to learn how to design slides, presentation slides. Okay, you're also going to learn how to create a portfolio, which means when you're ready to be thrown outside to the outside world, I'm going to be helping you review your CVs and also your LinkedIn profile. We're also going to help you build a portfolio. We are not going to do this portfolio for you. We are going to show you how to build your portfolio so that whenever you need to build your portfolio, you can know and learn how to do it yourself. So you don't need to call on anybody or rely on anybody. We won't teach you, but we want you to be able to do these things yourself so you can build confidence in yourself. And one important thing, please, guys, believe in yourself. You can do this. Data analysis, data science is not difficult. It's only difficult when you think it's difficult. Starting off might have a lot of friction now, but when you put yourself in the process, immerse yourself in the process, you find out that it's not difficult. Always speak to yourself in the morning and in the night that you can do this. You might not believe whatever you're seeing, but the truth is that whatever your ear is able to hear after a period of time, your body and your mind gets conditioned to that thing. So if if you have people around you telling you you can't do this, you can't do this, and you allow your ear to keep hearing that, over time you start seeing yourself believing that you can't actually do it. But even if people are saying you can't do this, and you are telling yourself every morning and every night that you can do it, trust me, you will be able to do it and you will see yourself do it. Okay, so always believe in what you believe. Believe in yourself. Believe that what you believe will play out. So be careful about what you say to yourself, which is very important. After you've learned all these skills and you don't believe in yourself, you might get to the interview room and the employer won't believe you because nobody believes in you until you believe in yourself. Okay, so please always say the right stuff. Sure, everything that please. In fact, we need to make you believe in yourself, right? So we want to help you with confidence, help you with everything. We want you to watch us do it. We want all of us to do it together, right? The first thing is watch us do it. Second thing is we're going to do this together. The third thing is we're going to watch you do it. And the last thing is you're going to be able to do it yourself without needing supervision. And once you're able to get to that first stage, trust me, you're going to tackle any problem it is you might face. Okay. And always remember you are not alone. Okay. Don't be a Man U fan, be a Liverpool fan at this point. You will never walk alone. So please, if you are supporting any club, throw that club on side. In this place, we work with Liverpool. Right. I'm not a Liverpool fan, but I love that their tagline, you will never walk alone. So we are not allowing you to walk alone. Okay. You would always have help when you need help. But remember, no matter how much I help you, if you don't practice this stuff, if you don't find out time to learn this stuff, you are going to be making little progress and you will think you're not progressing. But if you practice, keep practicing and ask questions, and we help you when you ask those questions, like we will always help you, you will see yourself improving. That's certain. Solid works. Always works. Okay, so do we have any question at all, might be outside or very clearly unrelated or anything? Um, open to answer your questions. Or if anybody has anything to say, and not be a question, anything to say at all, please go ahead. Yeah, Stephen, go ahead.
As for starting the classes, what time is the class? How many days in a week can we have the class?
Oh, okay. The information will be passed immediately after this call because we have the cohort currently ongoing now. Okay, and they are going into Power BI, and we think that the first and easy way to get into data analysis or data science is through Power BI because it's less coding It's less codey, so you don't have to be afraid. It's Power BI. So I'm going to be telling you how to download Power BI, and our resources are already in place, which means the resources you need for Power BI is already in check. So by before the end of the day, certainly before 4 o'clock, you get all the information you need. So most likely, just try to prepare so you don't get caught unawares. Most likely by 12 o'clock tomorrow, you should have your first session on Power BI. It's very less technical. We'll explain a lot of things. Everything I said on call will be broken down in the simplest form, and you're also going to have access to videos, right? Videos are imagery, cartoon stuff there. So you find it easy to learn. And also slides shared to everyone. Okay, so you get to work with these different cohorts, learn from people that are already above you. Okay, learn from those people, and you also be able to learn from yourselves. All right, so yep. So I think that's what we think the best approach towards it will be now. I hope that answers your question, Stephen.
Yeah, thank you.
All right. So if we're going to be going ahead tomorrow, we're going to be give a link where you can download the applications you need. Okay. Basically, for the Power BI, you just need Power BI. If you're using a Mac, an Apple laptop, I'm going to show you how to get around that. If you're using Windows, perfect. You don't even have issues. So do we have anybody using Mac, like Apple laptop here? Anybody using Apple laptop? Oh, thank God. Thank God nobody's using Apple laptop. All right, so since we're all using Windows, or we all aim to use Windows, I'm going to show you. Yes, you know. Oh, you're using app. Don't worry, don't call laptop. We'll discuss how you can install Windows on your Apple laptop. You can install Windows on your Apple laptop, so you can pattern your system to use both Apple and Windows together. We'll discuss that later on. So for other people using Windows, it's easy to just go to the app and download Power BI, and you'll be good to go. It's not hectic or stressful. Okay. So right, guys. Any question at all? Do we have any question? Anything anybody wants to say or anything at all? Okay, so this recording is going
Okay,
to be
I have
on.
a question. Sorry.
All right, go ahead.
Okay, you said something about that starting tomorrow by 12.
Yeah.
Isn't the morning? Sorry, 12 p.m.
Yeah, 12 p.m. It's not good for you, right?
I don't have It's not.